Part A of this problem asks us to find the smallest value of L that gives a phase difference of 5.65 radians for the two light waves shown in the figure. We remember first that the wavelength of light in a medium is equal to the wavelength in vacuum divided by the index of refraction. So light in the top pane of glass has a shorter wavelength by a factor of 1.60, and light in the bottom pane has a shorter wavelength by a factor of 1.50. The phase at the backside of the glass is equal to 2 pi times the number of wavelengths that the light travels through in the glass, and we have a similar expression in the bottom pane of glass. We can rewrite these in terms of the vacuum quantities and the indexes of refraction. And find the difference in phase, delta phi. It equals 2 pi L over lambda naught times the difference in indexes of refraction. And we're told that delta phi equals 5.65 radians. Solve this for the glass thickness L and substitute all the known values to find that the smallest value of L is 3.60 times 10 to the minus 6 meters. That's the answer to part A. Part B asks us to describe the interference if the two waves on the backside were brought back together. We know that when there is no phase difference, the waves would be fully constructive. When they are out of phase, with a difference of pi radians, they're fully destructive, and it's fully constructive again when delta phi is 2 pi. The case we have here is delta phi equals 5.65, neither fully constructive nor fully destructive, but is closer to constructive, so we'll call it partially constructive.